Okay, so this lesson is chapter 2 in the Algebra 2 book, and it's on relations and functions. And we're going to just review some basic definitions. An ordered pair is just a pair of numbers, so that where there's an x and a y, the x represents your input value, and y represents your output value. A relation is just a set of ordered pairs. So basically, there's more than one. An ordered pair typically is one by itself, so that's an ordered pair. A relation is a set of ordered pairs. There's like a block of them, like we have here. The domain is the input values or the x values. So in our example here, my domain is made up of the x values. So 12, 1, and -9 is my domain for that relation. The range represents the output values or the y values. So for our example above, the range would be 9, -3, and 8. For a function is a set of ordered pairs that has exactly one input value for every output value. So basically, the x values don't repeat. So if you think about a vending machine, and let's say it's 1, 2, 3, and say if I push 1, I get Fritos. 2, I get Skittles. And 3, I get cinnamon gum. All right, those are my outputs, and these are my inputs. So if I push 1, I get out Fritos. If I push 2, I get out Skittles. If I push 3, I get out cinnamon gum. So this is a function. My vending machine is working correctly. Okay. However, if I put in 1, 2, 3, let's say 4, let's say 1 is a Faygo, 2 is a Pepsi, 3 is a Faygo, and 4 is a Sprite. When I compare my input values, if I put in 1, I get out a Faygo. I put in 2, I get out a Pepsi. I put in 3, I get out a Faygo. I put in 4, I get out a Sprite. It's still functioning, because if I put in 1, I still get out 1 Faygo. There's no confusion. So yes, this is a function. So if we look at a different example, so if I put in 1, I get out a Faygo. If I put in 2, I get out Sprite. If I put in 2, I get out a Coke. If I put in 3, I get out a Pepsi. So the difference with this one, if I push a 2, I have 2 possible outputs I could get out. and you're not sure which one you're going to get, so obviously the vending machine is not working correctly. So this one is not a function because the input values repeat. All right, so if we look at this function here, how do I know it's a function? 3, 0, 4, 5, 6 represents my domain, and none of these values repeat. So if I graph these points, so let's say 3, 9, it's like right there, 0, -2, right there, 4, 11, right there, 5, 13, somewhere up here, and 6, somewhere up there, okay? So you're graphing just the points. Let's see if I make it a little darker. Okay, so when we look at our graph, we can tell whether it's a function by doing what we call the vertical line test. And the vertical line test simply says if I draw a vertical line anywhere on the graph, the line should only go through the function one time. So notice how this green line only touches once. Now remember, you can draw this line anywhere on the function, so it has to hold true for any place on the function or any place on the relation in order for it to be a function. So let's look at another example. Okay, so if we look at this graph, is this a function? Well, we need to draw a vertical line anywhere in the function. Represented by my green line. And you'll notice that this line touches here and here. So because it touches more than once, this is not a function. Let's look at another example. So again, draw your line anywhere on the function. And you'll notice here it only touches once, so it is a function. Okay, so that's the vertical line test. This is just some basic reviews. Cartesian coordinate plane has both an x and a y axis. So my x-axis is here. My y-axis is your vertical axis here. There are 4 quadrants in the Cartesian coordinate plane. First quadrant, second quadrant, third quadrant, and fourth quadrant. It goes counterclockwise. Okay, when we talk about ordered pairs, they can be shown with parentheses as a group of numbers, which is what we typically see them as. We can also graph them, or we can do what we call mapping. And ordered pairs are mapped, so we have a box for our domain, as represented here. Sometimes circles are used, or ovals rather. Same idea though. And so our domain here is represented by 12, 15, and 8. And then our range, a box for our range. And those numbers are 28, 30, and 20. And then we have arrows in between that represent what goes to what. So 12 is mapped to 28. So if I were to write the ordered pair, it would be 12, comma, 28. Same thing applies for the next one. So 15 maps to 30, and 8 maps to 20. Pretty basic. Because there's exactly one x for every y, we call it a one-to-one function. This is just another example of of mapping. So in this case, our ordered pairs, the -1 is mapped to 5, 1 is mapped to 3, and 4 is mapped to 5. All right. All right, here's another example. Same thing, similar idea. We end up with -3, 0, -3, 6, 1, 1, and 5, 6. And so because our x values, all right, x and y, two of our x values are the same, this is not a function. So the same rules apply. When we talk about different types of graphs, we have what we call continuous and discrete. Discrete just means points on the graph. So you normally see that with scatter plots in particular. So they're just points on the graph. They aren't connected. So we call those discrete. Graphs that have a straight line or a curve there's some kind of pattern that you can follow, we call continuous. So if I don't have to lift my pencil up from the paper to draw it, then it's continuous. Okay. All right, is this set of ordered pairs a function? If yes, why? Pause the tape right here and try to figure this out yourself. So when I look at this, I see, remember, x, y, x, y, x, y. I have two input values with the same value. So this is not a function because the input values repeat. In the second example, is this set of ordered pairs a function? Again, x, y, x, y, x, y. I look at my x's, none of them repeat. So yes, this is a function because the input values do not repeat. Okay, and that concludes our lesson for relations and functions.